Welcome back to Gophercises. In exercise 3, we're doing a choose your own adventure web application. So before we do that, quick background on what choose your own adventure is. So there's a series of books. I think there's many of them, I'm not really sure, but basically the idea was that you get to read the book, and as you read through it, you get to choose what your characters do. So rather than going from page 1 to page 2 to page 3, blah, blah, blah. At certain points, you'd get this option of like, all right, if you want to, say it's a zombie book, if you want to fight the zombie, then maybe you go to page 22. If you want to run from the zombie, maybe you go to page 84. So the book isn't sequential from front to back like a normal book is, but instead you jump all through the book depending on what you're doing. And the idea is that there's many different endings, there are many different options, you might meet different characters along the way. And they were usually smaller books, that kids would read, things like young adult type books, and they were never too in-depth because a lot of people wouldn't read all the story, and it's harder to keep the story going together. But they were really cool because you had a lot more control over what was actually going on in the story. So you could actually dictate, what your main character sort of did and some other stuff like that. And it was just always just a cool concept to me. So what we're going to do here is we're going to do a choose your own adventure web application. That's the same idea. Every page you're going to be given like a couple paragraphs of text or story or content or whatever. It's kind of like you're reading a chapter. And then at the end of that chapter, you have an option of, where do we go next? What do we do next? And sometimes you only have one option. Maybe that option is, go to this next section. But other times you'll have a couple different choices that you can make. And we're going to be doing this with a story that I wrote specifically for this course. It's not an amazing story, but I kind of try to pull some different things in from the Go community. So if you've been to Gotham Go or some other things like that, you'll probably recognize some of the topics and some things that come up like that. So getting started, So basically, I'm going to start off just by looking at the JSON. I want to look at the JSON that we're going to be working with, and we want to look at a way to parse it. So the first step, I should take a step back. We're using JSON because I just want to give you an example of how to use JSON. I think I mentioned this in another video, but one of the exercises we use YAML, one we use a CSV, this one we're using JSON. The idea is just to get you familiar with different encoding and decoding type formats and just learning how to use them with Go. So that's why we've sort of been jumping around with them. So this one, we're going to have this gopher.json file, and I'm actually just going to jump straight to, first I want to open this link, but I'm going to go to my code. And I'm doing this just because this is going to be a little bit better formatting, a little bit better color. So what's going on here is the first thing, this part here is what I'm calling the arc name. So basically our story is broken into many arcs. You could call them chapters, arcs, whatever you want to say. I ended up using arc for some reason, even though chapter would have probably been easier to relate to with a book, but whatever. So these are called arcs. And in each one of these arcs, we have this object here, which I'm going to highlight real quick, that represents the chapter or that arc of the story. So inside of that, so I should take a step. This part here, the arc name, is always going to be dynamic. So we have one named Intro, we're going to have another named New York, we're going to have some others in here, and the names of these are going to be changing depending on the story you're reading. So you can't count on those to be the same. So I'm doing this intentionally because I want to show you that you can use maps whenever you're decoding JSON. So we're going to be using a map to sort of handle that, where this key is going to be a string, it's going to be the key of the map, and then the value is going to be the story arc that it points to. So we'll end up having something like map string, if I could type today, and then we'll have arc or story arc or something like that. So this will point to some sort of object that is the story arc that key string points to. Okay, so we've got that inside of our story arc. So this is the part that is going to be shared across every different story arc. We've got a title, and the title is just kind of the name of the chapter. The story it's an array of strings, an array in JSON terms, so we're going to be storing it as a slice. And each item in the array is meant to be a paragraph. So I named this story intentionally because I want to show you that you can rename things whenever you're decoding from JSON back to your Go struct. I want to show you that you can have your names of your Go structs a little bit different than what the actual JSON name is and still make that conversion back and forth work correctly. So we've got their story paragraphs, and then at the end of the story, at the end of that chapter, you have these options. And the options are going to be an array of basically text and arc pieces that are inside of another type. And inside of this nested object, we are going to, basically the text is going to say what you get to do. So maybe you're in a zombie story, your option is slay the zombie or run from the zombie. Those would both be text options. Now the arc part here, this is going to be where you go if that's the option you choose. So in this case, it's going to be arcs like this, the names that we have for our keys inside of our JSON file. So we've got intro, we've got New York, and we've got some others. That's what these arcs are going to be. They're going to point to where do we go next, what part of this map do we load next. So now that we know that, what I'm going to do is copy this whole section inside of here, and we want to turn this into a Go type. So we want to store this in sort of some type of a struct inside of our Go code. We could try to do maps or things like that, and there's a couple of JSON packages out there that let you sort of dynamically pick pieces out of a JSON file, but that's not what we want to do. There's no real reason to be doing that. We know that this section that I've highlighted is always going to be roughly the same. So let's just go ahead and turn that into a struct. So I'm going to be using this, I have it linked in the exercise page. It's this tool by Matt Holt, who's the creator of Caddy Server, and it is this JSON to Go tool. So what it does is it allows you just to paste some JSON here, and it automatically spits out a Go type on the right-hand side. So we're going to go ahead and copy that, come back to our code, and we're going to, let's do story.go. So I'm going to create this story.go, and I'm going to make it in the package CYOA for Choose Your Own Adventure. And I'm just going to paste that in there. And then I save it. So I've got this story.go on the left-hand side. So looking at this, we're going to want to break it up a little bit, but this is an object that represents the chapter section of our JSON file. So we might want to name this arc, chapter, whatever makes the most sense to you. I'm actually going to name it chapter for the videos. I might go change the exercise description a little bit, because I feel like chapter is a better choice, but I don't know why I didn't think of it at the time of setting it all up. And another thing I'm going to do is this story part. I told you that you could rename that to something else if you wanted. In our case, it's going to be paragraphs. And I'm doing that because I think that's a little bit clearer as to what they represent. And when we go to render them, we're going to want to put some space in between each different string in the slice, because each one is a paragraph. Going down through here the rest of the way, we've got this struct type that's inside of our options. So the code here works and it's fine, but I kind of like to break these types up into their own, because maybe you want to manually create an option inside of your code or something like that. It's often a lot easier if you actually have types defined for all of these. So I'm going to take this all out, and I'm going to do type option, which is a struct. Well, I'm going to paste in what I copied. So it's a struct, and then it's going to have that text piece and that arc piece. And for this arc piece, maybe we would name that chapter as well here, just to sort of map the chapter thing that we have up here. So now that we have that, we can come up here and we want to change all of this. We don't want to inline the struct, we want to make it an option. So we're going to say options is a slice of options, and it has the JSON key of options with the lowercase o. Okay, so that's everything there. Before we go on, I do want to mention one quick thing, which maybe I've shown you this before, but if you are using Atom and you have Go+, and I think Go+ is the only real plugin you need for this, you might have something like name, age, int, some struct like this. If you highlight that struct, and in Mac it's Command-Shift-P, that'll bring up this dialog. This is sort of just like different actions you can take. And if you type in Go tags, I think it's like, it's Golang add tags. So this will allow you to add tags to structs that have whatever type you want. So say we say JSON, and maybe we have some options like omit empty, and we're going to do snake case, so we can add that. Then we can submit, and you'll see here that it'll actually put tags for all of these fields, and snake case is converting these all to snake case for you. So that's something you can do with depending on the editor you're using. I'm just showing you real quickly because I think it's a really nice feature to have whenever you need to use it. You can also do multi-select things, stuff like that, to get around it if you aren't using it. Okay, so back to what we're doing. I am going to add one more thing to this. So I told you that we're going to be storing our stories in a type that's like map string chapter. So it's going to be something like this, where each string is really a chapter name, and then it's going to point to that chapter. that's the exact format we have here in our JSON structures. We have a bunch of these keys and they all point to a chapter. But we don't necessarily want to make the end user think about that. So what we might want to do is do type story and just go ahead and say that this is a map of strings to chapters. So now whenever the user's coding things, they can only worry about the story type. They don't really have to worry about creating a map or thinking about a map as much. Just makes life a little bit easier, in my opinion, to just go ahead and define that for them. Next, we're going to set up a command to run our server. This is going to start off pretty basic, and then we're going to slowly change it over time. In the past, I think in the last couple exercises at least, I think we've just had like an examples directory. In this one, what I want to do is, let's say CYOA web. Yeah, that seems fine. So what we're doing here is we want to create a command, and usually what you tend to do, well, you don't have to, but a lot of people tend to do, is they'll create a command directory, just a CMD directory, and then inside of that, for any commands they want to add to their, their application that they're making or whatever, that you can create a folder for each individual command, and then inside of that, you're going to add your main package source files that you would end up building, and those are your commands you actually get to run, like as a binary. So in this case, we're going to have a single binary we use to start up a web application, but our choose your own adventure code is actually going to be in a package that's mostly broken apart that you could reuse into other things if you wanted. So we'll do main.go here. And let me just go ahead and, so we've got this. So basically what I'm saying is, I think I need to put start.go. Yeah. So it ended up naming it main, which is fine. If we built it from inside of here, you'll see here that it ends up naming it CYOA web. So we can just do like this. It just runs that program. It gives us a binary that we can run. So that's kind of where the naming comes from. By default, if you're just in that folder and you just go build from it, it'll just name whatever that directory name is. And maybe we want this binary to be CYOA web, but I'm going to remove it for now. And I'm going to go back to our main directory, and I'm going to remove the main binary as well. And yeah, I think we're good there. Okay, so we're going to have that, and basically inside of this, what we want to do is we want to run our web application when we finally have it, but for now we're just going to kind of use it to experiment and make sure what we're writing works. So to start, we want to open up our gopher.json file, and once we open it, we want to go ahead and make sure that we can parse it into our story type, to make sure that all that JSON code we just wrote is correct. All the struct tags that we have are right, and all of this decoding is going to work properly. So let's just go ahead and start off by doing that stuff. So we're going to start with a flag, and I'm going to make it a string flag. It's going to be file. The default is going to be gopher.json because I know that's the file we have. And then we're going to say the JSON file with the choose your own adventure story. And then we're going to do flag.parse. So this will make sure all our flags are getting parsed. So now we have that option. And if we want to go ahead and let's just print this out so it's clear what file we're using. Parsing the file, or let's just say using the story. Using the story in %s. And then for %s, we're going to pass in that file. This is really a file name, but I think that's fine for now. Well, we can change it. Just make it file name, paste that there. And I'm not sure why it's complaining right now. Oh, it's flat. I put flat instead of flag. That's my fault. No wonder. So from here, I'm going to go ahead and go run, and I'm going to do command CYOA and main.go. And I'm just running it instead of parsing it instead of building it just because we can. And you'll see here that if I put help, it's got this file option, and we can put something else like file dog.json, and we get dog.json. But we aren't going to be doing that. We're just going to be using the gopher.json. Okay, so now we want to open up that file. So we're going to say f comma error is os.open file name. And once we're going to need to put an asterisk here because it's a pointer. And then we need to make sure there's no errors. So I'm going to put panics here. I'm not sure what all you've read or heard about error handling in Go. Usually panicking is not a great idea, especially nested inside of code. In this case, it's still probably not an awesome idea. You probably would print out a more logical error message for the end user, like we couldn't find that file or something went wrong, whatever. But in this case, I'm just going to panic because it just gets the job done for the time being. And then we want to decode that file. So we're going to do json.new decoder. And a JSON decoder is kind of like if you've used json.marshal and unmarshal. Those ones you pass in byte slices. For the decoder, you pass in an io.reader. So any file we open is going to be a reader. So we can just pass in that file to our decoder. And then we can do var story cyoa.story. So that's a choose your own adventure story. And then we're going to do if the error is equal to d.decode. We'll pass in a pointer to our story, and if the error is not equal to nil, then we want to panic. So this is, if we end up getting an error here, we're going to go ahead and panic. And I think that means if that does not panic, that means that we should have a story decoded. So let's just go ahead and print that out. And let's just do %+v. So %+v, what that's going to do is it's going to %v will just print out the entire struct. It's pretty verbose, it'll print out all the fields. And then the %+v will print out the field names as well. So we'll see things like paragraphs, colon, and then whatever the paragraphs are. So I like doing that whenever I'm printing out a struct just because it's a lot clearer as to which fields are which. All right, let's go ahead and run this and see what we get. So the fact that we have a lot of output here means that it's likely working. We would probably just have an empty story if that wasn't the case, so good sign. Looking at this, it does look like most of this is what we were expecting. I do want to mention one quick thing at the end. Options can be the empty, like an empty slice. That usually signifies that it's the end of the book, or maybe you hit one of the endings. It might be multiple endings. But that's just, so it is possible those can be like that. So that's why this last one is actually an empty slice. So that isn't an issue. Okay, I think that's all of it. So let's look at how we can refactor this. We've got it working, but it's not exactly the best code. So in this video, I'm going to try to do this whole write some code, get it working, and then refactor into something that I might actually want to ship to production or send off to other employees to look at. Because this isn't necessarily code that's going to be easy to maintain in the long term. So how can we make this better? Well, the first thing I notice is that this JSON section, a lot of this is going to be code that realistically, you're going to be writing a lot. We know that most of these stories are going to be coming in JSON format, and or at least we know that's probably going to be a common format for it. And it might make sense to take the JSON parsing part and stick it inside of your story. So maybe here we can put func JSON story, and maybe it takes an io.reader. And it returns either a story or an error. And inside of here, we can paste that code that we had. So this isn't quite right. I need to change this to be R, but we do create a story or decoder. We then take our story, we decode into our story. If there's an error, we want to go ahead and return nil and then the error. And assuming there is not an error, we want to return story and nil. So I know this isn't a ton. It's actually not going to make our code that, I need to change this. I don't want that to be CYOA because then we'll have a cyclical import. This package is importing itself. So basically what I want to do here, what this is going to do is it's going to allow me to come here and basically just say story comma error colon equals cyoa.json story with F. And then I can delete those two lines, and then for this one I can just delete that section. And it really doesn't simplify our code that much. It's not like maybe we lost a line of code there, but the bigger point here is that this is just a function that more than likely makes more sense inside of this package. Maybe it doesn't, maybe it does, it's up to you, but I think it's fine to put in. I think it's good to put in here because I think we're gonna have a lot of JSON stories. So let's go ahead and run this again, and you'll see that it looks like it's still working. It might be in a different order right now. That is something to keep in mind, especially with maps, is the maps don't have a set order in Go. So you can't guarantee the order is going to be the exact order we put the things in there or the exact order that the JSON file was in. So just keep that in mind when you're using maps. They aren't a guaranteed order, and if you need that, you need to store it some other way. Next, we're going to look at how to add an HTML template to our application and start rendering our stories. So to do this, we need some sort of HTML. So I'm just going to go ahead and just start up a new file and set the grammar to HTML. Actually, let me go ahead and HTML go. And inside of this, we just want to sort of put some HTML here that will represent our story. So this will get us a good chunk of this stuff. Choose your own adventure. I don't think we need a lot of this. So here we're going to put a heading, and the heading is going to be the title of our story, or the title of our chapter. So you'll look back here, we've got this title. So actually, I'm just going to copy this and go into here. I'm going to put it down here inside of a comment. And I know that we're going to want to use a title here. So this is how I don't know how familiar you are with templates, but with templates, I'm using the HTML template Golang. I'm going to be using the template package to render this. So inside of here, it's got a whole lot of details. I think I've even written a bunch of blog posts about this, but basically it's a way to render some HTML or other types of templates with Go. We're going to be using that right now to render this HTML page, and we're going to go ahead and just start putting these fields wherever they would go in our HTML. So we've got the H1 tag, which is the title. We're going to want to range over the paragraphs, and we'll end that then. And then inside of this, it's going to assign each paragraph to the dot, so we could access each individual paragraph like that inside of this range block. And we want to do each paragraph, but we want to put it inside of a p tag. So let's do that. And actually, I don't need to indent that. And then after that, we want to go ahead and give them some options. So I think we'll do an unordered list here. And then we're going to, again, range over the options. And then for each of our options, we want to put something like li. And I'm going to indent that just to keep this consistent. We want to do li. We'll have an href to something. I'm not sure what yet. And then we're going to have something here. So let's go down here to the option. So chapter is where the href is going to go to. So it's going to be / then chapter. So we're just going to assume that our handler is going to, whatever the path is, that's the chapter name. We might eventually need to tweak that a bit, but for now, I think that's a fine assumption. And then the text is going to be the text here. So I should say this entire option object is what's in the dot operator. So that will access the entire option. That's why I'm able to do things like dot chapter and dot text. Yep, didn't want to save that yet. So that's our entire HTML template. We could save this as a file and then try to parse it and load it and things like that. I'm actually just going to copy all of this. And inside of our story.go, I'm just going to slap it in here as a variable. And I'm doing that because this is meant to be a relatively simple template, and it's just a little bit easier to have it inside of our source code rather than having to, sort of package that file with the source if somebody were to install it or something like that. So we'll say default handler template is equal to this. We'll just paste it in. And these backticks allow you to do multi-line strings. That's why I'm using them there. So that gives us a template to work from. Now we want to go ahead and create a handler to render that. So we want to return something that can be used in web applications to handle web requests. There are basically two ways to do that. So let's go to HTTP Golang. The first we looked at in the last exercise, I think. It's the handler func. It is down, where's it at? There it is. So it's this handler func type. It's really just a function that has response writer and request as the two arguments. So then there's also the handler type, which is an interface. And this is just anything that has the serve HTTP method that takes in a response writer and a request. We already looked at how to do the handler func in the last video, so we're going to use a handler interface in this one. There's other reasons for it, which we'll get to at the end of the video, but I just want to show you how to do this, and we could actually do it without the handler interface, so it's not like you have to, but it's just what I'm going to use because I think it makes it a little bit easier. So we're going to go ahead and add a function here. We can add it kind of wherever we want. I'm going to do it here. Say new handler. And this is going to return, it's going to take in a story, it's going to return an http.handler. So I could return a specific type here. There's really not anything in particularly wrong with that, but the only thing we really want people to be using this for is handling web requests. So in this case, I'm going to return the interface. There's a Go, I think it's a Go idiom that's something like return structs except interfaces, something along those lines. What it basically means is be a little bit more forgiving in what you'll take in for data. Be more generous to let them pass in whatever they want to pass you. But when it comes time to returning, since you know the type of it, you could actually just return that explicit type and they can do whatever they want with it. It doesn't have to be forced into that interface. In this case, I'm just returning the interface because I feel like that's the only real use for this. So I think it just makes sense to do that. And it makes it a little bit more explicit with your docs that that's really what that's intended to be used for. That also means that we can create our handler type internally and it doesn't have to be exported. So I will show you that here in a second. We want to return a handler, so we need to figure out what that handler type is. We're going to name it handler. It's going to be a struct. So what I meant by that was we could technically return handler here, return this type. That would work fine. The downside to that is if you were to create Go docs for all of this, any methods on this handler aren't exported. You don't get to see them, so I can just show you that. http.responsewriter, http.request, and just save this. Return handler. And then if we were to, I think it's Go doc. Let's do help first. I think it's HTTP, yeah. I think it's, let's do 3030. Localhost 3030, and then I want to do packages, GitHub. I've got so many random things here that this is going to take a second. All right, this is what we want. All right, so what I was trying to get to there, I know it took a bit to get here. We've got, that's not right. So we've got H handler, and yeah, I don't need to restart that, but I'm going to. All right, so you're looking here, you'll see the handler type is never exported. So when we're looking at this function new handler, this type doesn't get exported. So you have no idea what methods it has. Even though the methods on it are, capital letters, they're exported, you can use them. You don't really have any documentation for it. You have no real idea of what they're being used for. But if we were to change this to http.handler, all of a sudden, when we come back here and look, it's a lot clearer as to what this is intended to be. You can click on it, you can go to the type, you can see what it's supposed to be, and okay, it's gonna have the serve HTTP. So that's another thing is if you're not exporting a type, I generally don't like to return it. You just that type explicitly. I'll usually, whatever interface I expect it to be, I'll return that because it's really not going to be clear to end users what methods that type has. Okay, now that we have this, we need to use it to render this template. And that means that we need to, first we're going to store the story here. So this will be the story, and we'll put the story inside of it. And then inside of this serve HTTP method, we can now access the story with h.8s. So, we can do intro to get the intro chapter. So we're going to start by creating our template. Excuse me. We're going to do template.must, and I'll talk about this in a second. So I'm going to do template.new.parse, So I'm doing the empty string for the name of the template because it really doesn't matter. We're not defining anything specifically. And parse is going to be the file or the string that we want to parse. So I'm going to do default handler template. And yeah, that should work. So we're using must here because this template up here, realistically, if that template doesn't compile correctly, it means that our code really isn't ready to ship. It's not something where if it does crap out at runtime, it's not really something we can handle there. The template needs to compile in order for our code to be useful. So I'm using template.must here because there's not really a recovery option for this. And even if we tried to, it wouldn't make much sense. So we're going to be using template.must here. Now I will say that a lot of the times what you'll see people do instead of this is that they will run this template.must when this code's initializing. So maybe it would be up here, we do something like var tpl template.template, and then maybe you do something like func init, and init will get run as soon as or whenever the package is being initialized. So then we could do something like tpl equals template.must blah blah blah. So that's an option here. It works completely fine. I'm not doing this right now, strictly because we're gonna get rid of a good chunk of this anyway. Actually, we can keep that. That actually won't ruin what I plan on doing. So I'll do that, then we can get rid of this. So we have our template, and it's up. It's a global variable in our package, but that's fine for the time being. It's not exported, so it's not like we have to worry about that. It's just kind of a hidden thing in here. So once we do that, we want to execute this template and we want to pass in some data to it. So we want to pass in a story. We don't have a way to figure out which story we should have. So what we're going to do now is we're just going to choose a story. We know there's always an intro story because if you look at the exercise, at some point I talk about here where there's always going to be a key with the name intro. At least that's like a generic rule I made. So I know gopher.json has an intro. So we're going to go ahead and use that. So error : equals tpl.execute. We're going to pass in w, the response rate, so we're going to output we're going to write to when we execute this. And our data is going to be the story, the intro chapter of that story. And then we're going to say if the error is not equal to nil, and we're going to panic here, which is not normally a good idea. But now that we're in development and we're just kind of getting this working, I think that's fine. So assuming that's all there, it's all right. We want to go ahead and make this work. We want to see it in action, I guess, is what I'm trying to say. So I'm going to go back to our main.go, and I'm going to add a port flag. It's going to be port. Default's going to be 3000. The port to start the server. The CUI away web application on. So we have that. What we want to do next is we want to take this, get rid of it, and we're going to do, so we're going to pass in the story that we have, and we're going to get a handler back. And then we're going to print out that we're starting the server on port %d. Let's say at, and there's 2%d. That's fine. Just gonna do it this way. Then we're gonna log.fatal. So we're gonna http.listen and serve, which is going to start up an HTTP server. And log.fatal here, what's happening is if this whole thing returns, it shouldn't return as long as our code's running. The server should just keep on running indefinitely. But if it does, it's probably gonna return an error. I think that's all this returns. Yeah, it's an error. And whenever it returns that error, it's just going to pass that to the log.fatal, so we'll get to see it in our screen. So that's why we're wrapping that. So here we want to do %d, pass in the port. So we're just creating a string with the port at the end, and localhost is what's going to get used by default. And our handler, we're going to pass in this handler that we created up here. Assuming that I did that all right. I'm not sure. I don't know why this is complaining. Oh, I named it new handler instead of new handler. That would explain it. Okay, So I don't know why that's, oh, this needs to be printf. Okay, so I think that's all of it. I'm gonna go ahead and run it. We're starting the port on 3000. Let's see what happens. All right, so we've got our story here. We've got the little blue gopher, except no matter what link we click, it doesn't do anything, but that's fine. We've got it rendering the story. Doesn't look great, but it's there. So our next step is going to be to parse paths so that we know which particular story chapter to render. So we're going to go back to our code here, and inside of here, we need some way to figure out which chapter we're on. So we can get that from the request. We're going to do r.url.path, and that'll get us the path. And we're going to do path : equals, let's go ahead and trim this. So we'll do strings.trim space. So really all this is doing is just getting rid of trailing and leading space. There shouldn't be any on this, but I'm just going to put it there for the heck of it. Make sure it's trimmed. The next thing we're going to say is if the path is equal to the empty string, or if the path is equal to the slash. So either of these are the case of just going to localhost 3000 with no path at all. And on those, we want to default to intro. I think I talked about it. I mentioned it here, I know. But basically, whenever there's no path or no specific chapter, I'm just going to assume we're starting the story from scratch. And at that point, we're just going to take you to the intro chapter. So we'll do path equals /intro. So I'm just going to go ahead and say, make it the same as if they just typed in /intro. And then the rest of our code, when it comes time to parse, we'll actually get rid of this preceding slash. So then we're going to say path equals path 1: and this is saying, give me all the parts of the path string from index 1 onwards. So it's going to get rid of this preceding slash, the prefix that's a slash. And that will get us something that's like just intro. So assuming that's working correctly, we're going to do if arc, actually let's do chapter, okay, : equals h.story, path, and if everything is okay. So what's going on here is whenever you access a map like this, that's what we're doing. H.s is the story, which is actually a map underneath, behind the scenes. So we're passing in the path key, which is going to have a value like just intro. So this part here will take something like /intro and convert it into like intro. And then when we call this part here, what's really happening is we're passing in something like intro. So it's pretty much the same as what we did down there. And when we pass this in, the first argument returned is going to be the actual object stored in the map. So in this case, it's going to be the chapter. The second object is going to be whether or not it actually found that key inside of the map. So you don't have to provide this. You could just do something like this, but then you wouldn't know for sure if it was found in the map. You might just have an empty chapter here. So we're going to go ahead and put the OK there that says, all right, only do this if you actually found something in that map. And it's kind of, there are times where you don't really care if something's in the map. And then there are times where you do care. For example, if you just want the default value and then you're going to fill it in and replace the map entry, then you don't care too much if it finds anything. But in our case, we do actually care. So here we're going to do, I think we want all of this. So I'm going to copy it, paste it up here, and we're going to replace this with the chapter that we got from our story. And we'll do the same old thing. We'll get rid of this for now. We'll do log.printf, and we'll pass the error, and we're just going to print out the error just so we have it in our logs. And then we're going to http.error, and here we're going to go something went wrong, and we're going to do http.status internal server error. That kind of represents like something went wrong on our server. We're not really sure what. Because if the template doesn't execute correctly, it really means we messed something up. And one thing I want to point out here is that I'm not passing this error message directly to the output. So this is something I see a lot of people do at times. And when you're in development, it's fine. You're just trying to see what's going on. It's whatever. But whenever you actually have a production application, you generally don't want to expose random error messages to end users because it could give away a little more information than you intended. For example, maybe that error message had something about your database string and your string has the password in it. You don't want them to know that. So you really want to make sure there's messages like that. You don't just throw them out to the end user. You only show them messages you explicitly designed for them to see. So usually you'll have something like this. You'll log the error to your standard error, or to your logs or whatever, and that's only visible to you. It's not going to the end user. And then to the end user, you use something like just a generic something went wrong message. So assuming that this needs to be in an if block. So this is only happening if the error is not equal to nil. And regardless of whether or not the error was nil or not, if we're inside of this, that means that we found our chapter. So we're going to return. Otherwise, this means that we didn't find the chapter. Chapter not found. And we don't really need the dot there. And we're going to put http.status not found. So this is a very different error. This is the type of error you return if a resource could not be found. So maybe they give you a bad URL. It's you've probably seen 404 pages. It's the same thing. We're saying we couldn't find whatever you're looking for. So maybe they typed a chapter name wrong or whatever, or maybe our code has a bug. It's really hard to say, but we're going to go ahead and display chapter not found when we couldn't actually find a chapter for that person. And I'm going to get rid of some of these comments here. I think that's it for this. We could take these error messages and make them constants, at the top of our file. I'm going to leave them here for now because we're only using each one once, and I think that's fine. And I'm going to go ahead and test this out and see how it works. So let's, I want to go right here. If we click on New York, you'll see that our story is now working. Well, it was. It's still working. I just clicked on the wrong link or went back too far. So we're getting different chapters presented here, and this story is not really, really long. So if you want to go through it, you definitely can. You go ahead and read it just to see if you enjoy it. The next thing we're going to do is look at our code and see how we can improve it. So I talked about it earlier where we added the JSON story function. What we have now works, but it's not really extendable. It's not easy to change, and some of it is kind of not easy to test either. We've got templates that are global inside of here. You can't add your own template if you want. You can't. Maybe you want to use a different path structure for all of the stories. So maybe they're not always going to be /intro. Maybe it's going to be /stories/intro or something. I don't know. But basically, our code is pretty static right now. It doesn't let you do much as far as options go. So we're going to look at how to use different types of options to improve the story. But before we do that, I just want to I want to style our HTML a little bit just to make the story look a little bit better. So I'm going to grab some styling that I wrote up ahead of time, and I'm just going to put this. Let's just put it. I think I can put it right there. I think that's fine. Probably should put this at the end of the body. I don't think it really matters, but put that there. And I'm doing it as a style tag here for a couple of different reasons. One, I don't want to set up a static file server to serve a CSS file, but two, because this is pretty small, so there's no real reason not to just sort of inline it. I know a lot of people with big applications will be like, oh, that's a really terrible thing, but it honestly, for really small things like this, I think it's fine, especially when you just want this single handler to work. So let's go ahead and test it out. I don't think that's working correctly, so I'm going to pause this and figure out what I'm missing. Remembered what I was missing. So I forgot to add I forgot to add an HTML tag that I used whenever I made the styling. So first we're going to want to do a section, and we need a class. We're going to name it page, and I'm going to take all of this, tab it in a little bit, actually, and then I'm going to close out that section. So this section is going to be just sort of a container for all of our stuff, and I'm going to name it page. That way this CSS down here with .page will actually work for it. And then the next thing is, I actually don't think I had any other classes. I think that's it. So I can restart this. And I do need to restart because all of this is kind of hard-coded in there, so the HTML changes aren't going to get changed. And you'll see here now our story looks a little bit better. It's not perfect, it's not amazing, but This is a little bit better than it was, and it looks more like a storybook. So we've got our options, and we can go through here. So we've got our styled story. So now it's time to look at how to make our handler a little bit more dynamic, a little bit more, open to having some custom options. We're going to start by adding custom templates, and I'm just going to show you how one way to do this, and then we're going to look at how to use something called functional options to make it, in my opinion, a little bit better. So we're going to start just by doing ttemplate.template, and I'm putting this inside of the handler because we need some way to define what template this handler is going to use, but every handler we have could use a different template. So, we need to make sure that every time we return a new handler that, maybe one's going to have a custom template, one will have a different custom template, and maybe one will just not have a template at all. So, or, we'll use the default template. So we want to go ahead and make sure we have that. The next thing we'd want to do is up here in our new handler, we'd want to do something like ttemplate.template, and let the user pass in a template. So, maybe you built a template on your end and you want to pass it in. Now we need to make sure that something's provided, and if it isn't provided, we want to use a default. So we're going to do if t is equal to nil, so that means one was not passed in. We're going to say t equals tpl, so that's that global template that we created. And then down here, we're just going to pass in whatever template we have to our handler. So, if it was nil, we would go ahead and set something to it, but regardless, something's going to get set here. So that handles everything we needed there. Looking at, I think that's it. So we can restart our server, and it's not working because we didn't update our main.go. We want to do nil here. And you'll see that this is working now. The page seems to be working. And we're still using the default template here. But if we wanted to pass in a custom template, we could create one here and pass it in there. I'm not going to do it just because it takes a little bit more time to code that all up, and we're going to throw it away here in a second. So the next thing we're going to discuss with this is basically different ways to change these options. So if you look at this, if we started adding a bunch of options to our code, like say we had maybe we needed a different parsing function, how we're parsing this path here. Maybe we needed something different in case our template, maybe we're creating paths that are story, maybe it's going to be story name / chapter name. Maybe that's what the story is going to end up looking like. Well, knowing that, it really doesn't make a whole lot of sense to force them to use our path parsing code here. Maybe they want to provide their own and allow them to make different paths like that. So what we're going to do here is maybe we'd add a path func, and this would be a function. It would take in the request and it returns a string. Well, you'll see that very quickly this is going to get pretty tedious. We're going to have a whole bunch of different options passing in here, and if you don't want to customize them, it even it sucks a little bit more because now you got to pass in nil or you got to pass in something and let it know that you don't want to customize those. So what we're going to do is we're going to look at different ways to sort of provide options to functions without being forced to pass in a whole bunch of things. So the first is to create a type. Maybe it's going to be something like handler options, and it's going to be a struct, and this would have all your different options. So maybe it has a template, maybe it has a parsing func, and it's going to be a function of http.request and returns a string. Maybe we have a bunch of different things like this that all get slapped in here. And then for here, you would have the option is going to be handler ops. So, they can pass in whatever options they want and sort of go about setting it all up with that. So the upside to this is that it's relatively straightforward, simple to code. Most people can come up with this on their own. The downside to this is that what if you don't have any options you want to pass in? Or what if two of your options need to be passed in together? For instance, maybe you have a database, and to connect to it, you need a username and a password and an address of some sort. So you need 3 different options. Well, now if you've got 3 different fields on your handler options, it's not entirely clear that all of those have to be paired together. Well, you could do some things like nested types and stuff like that to sort of make it a little bit clearer, but sometimes those things will be shared. Like you might have one variable that if it's true, another thing can't be false. You have a lot of dependencies here that can be confusing. So I tend to not lean towards this because it's just not as clear what's going on. And it's also a little bit weird when you're thinking about default values. If you don't pass anything in here for the template, does it get a default value, or do you need to set it as a default value of some sort? So, it's just a little more confusing that way. Another thing is you have to provide this option here. One way to get around that is you could just put ... here to make it a variadic parameter, and now you can pass 0 or more options. But that kind of leaves the open-ended part of, what happens if they pass 3 options? It gets a little bit weird. Which one do you use? Do you just return an error at that point? Well, what if your function didn't return an error before? So, it's just another case where your code isn't as clear as it really could be. So what we're going to do is use a different design pattern. And this is one that Dave Cheney has talked about a lot, and I really like it a lot. So I tend to use it possibly more often than I even need to. And it's called functional options. So the basic idea here is that you have a type. Well, you don't have to have a type, but I'm going to create a type. It's going to be a handler option. It's going to be a function that takes in a handler. And this is going to take in a pointer to a handler so that it can modify it. So what this allows us to do is, now this is still going to be handler options. You're going to still pass in many of them potentially. I'm going to change that name though. So what this allows us to do is create functions like a function with template, and the user will pass us in a template. And we're going to return a handler option with that template. So we're going to say handler option. So here we're going to say return function. So a handler option is really this type of function, so we're going to return that. And inside of this function, this this closure we're creating, we're going to say that the handler's template is going to become the template that the user passed into us. This one up here is T. So what's going on here is this code here is accessing this type that's not exported. It's accessing this variable that the end user never really gets to interact with directly. At least they get to interact with it as an interface, but they don't get to interact with it directly as that handler type. And it's setting some data on there. And then it's returning this function that does that work for them. So I'm not going to go into a ton of details here as to what functional options are. I think I do have the article. Yeah, I have the article up here. I think Dave also has a talk about this. I forget where it is though. Definitely check that out for functional options. It's a really cool thing. But the basic idea here is that we can provide these functions that allow us to set options like this, and it's very clear when we're doing them which ones you need. So if you needed 2 different settings here, like I said about if you were setting up a server and you needed with database, maybe you need a username, a password, and they're both strings. Well, now it's very clear if you want to use this option that you have to provide both of those pieces of data there. It's not ambiguous or anything like that. It's really clear, hey, we need those. So what this is going to do is it's going to allow us to sort of just apply those options, but we need to make sure they actually get applied. So we're going to come down here to the new handler function, and inside of this, we're going to just first set up a default handler. So we're going to say h:= handler, and the story is going to get passed in, and we're always going to require a story here. I'm not making that an option because a story is required. So a lot of things that end up being required, you'll have as arguments to this new handler function, but the options are sort of meant for optional things, and that's why we're doing it this way. And then I'm actually just going to use the global TPL variable. That's going to be the default template. Now we can still use this right here option to overwrite it, but for now it's fine just to use it, or we're going to use it to start off so that it has to get overwritten with an option. And then we're going to return h if everything goes well. Well, everything will because we don't have errors here. So to apply the options, we're going to iterate over the options, and we're going to just do opt and h. So we're passing in a reference to the handler that we have. That way it can be modified. So if we didn't pass in a pointer here to this handler, a reference to it, basically if this wasn't a pointer, what would happen is the changes wouldn't be persisted. But because we're using a pointer, the changes to, say, the template being used are going to be changed, or they're going to be carried over here, so we'll have that here. So with all of that, the way we would end up using this in our code is something like this if we just wanted to keep all the default options. But if we wanted to start passing in custom things, we'd do something like chooseyourownadventure.with template, and I'm going to pass in nil right now. But you could pass in a template there. So that's kind of what this ends up looking like. Actually, I'm just going to go ahead and create a template to show you. TPL equals template.must, template.new, parse, hello. So this won't have any variables inside of it, but it's just going to be, it's printing out the string hello. And I'm going to pass that template in there. That's the custom one we're using. And if I restart the server, come back here, we're not using our template in our code yet. So that's part of the issue. Coming back to our code, we need to come down to this, serve HTTP. Instead of using the global TPL, we want to use the handlers template and execute it. So if we refresh, it's just printing out hello. It's not even looking like HTML because the browser doesn't know if this is an HTML response. And if we come back to our main.go, if we just get rid of this option and get rid of that template there and restart our server, you'll see that we still get the default template here. It works completely fine. So we can take this a little bit farther. I mentioned earlier that maybe you would want to, inside of here, maybe you would want to put custom paths here, parse different paths in different ways. Maybe we just don't always want to use the same path parsing code. Well, that's also something we can add as a functional option. So we're going to do path function. It's going to be a function that takes in the request and returns a string. And then for this, we'll copy all this code and we're going to put it into a func default path function. And this is going to be, it's going to take in an http.request and it's going to return a string. So we're just going to say return. And you'll see here that this is all the same code we had before. We could just do default path function, call it there. But we're going to go ahead and instead of doing that, we're going to copy the name of it, and we're going to pass it in as the third argument, and we're not calling this function in this case. So when we were calling those options, we would actually call this function because it returned another function. In this case, we're just going to say the function itself is the argument we're using for the path function, and so that's what we're doing there. And then as we come down here to our serve HTTP, we do path : equals h.path function, pass in the request. So it really simplifies our serve HTTP code a lot. So that is a nice perk to this. It's also the type of thing that could make your testing a little bit easier, depending on what you're doing, because now you can just sort of make the path function always return certain things whenever you want to do tests. So you don't really have to worry about using specific paths. But we're not going to touch that just yet, or today actually. So if we restart this, you'll see that this is all working. But I want to show you this path function, like how we could go ahead and put a custom one here. So first we'll go up to here and we're going to do func with path func, and we'll say this takes in a function, which is a function like that, and returns a handler option. And path function is probably not an amazing name for this. But it's fine. I'm going to leave it be for the time being, because really it's being used to parse the chapter. But I'm just going to let it be. Return func. So we're returning a closure here, where we're going to set the path function to be the function that was passed into this function here. So that's what we're doing with this. And then if we go back to our main.go. Inside of here, maybe we wanted to create a path function. It's going to take in a request. It's going to return a string. And what we're going to do here is we're going to write a path function that expects the prefix to be something different. So I'm looking for the default code. We're going to grab it. And it's going to be something like stories/intro. So just something like this. And I'm just doing this so you can sort of see how it works. And we're going to go ahead and change this to be if the path is equal to /story or /story with the trailing slash. Then we're going to assume that we're at the intro. Otherwise, we're going to return, we want the length of that. So what we're saying is we want to get rid of all of this preceding stuff. So that's what we're doing here with the length part. So all of our paths are expected to have that story. And then we're going to go into story.go, and we need to change our template. So I'm going to copy all of this and go to main.go. We're going to make this story temple. And these paths are going to be story/chapter. So they're going to match that path that we're doing. And then we're going to go ahead and make the template. TPL equals template.must, template.new.parse. And what did I name this? Story temple. So here we're going to go ahead and add two options. We're going to say cy choose your own adventure.with template TPL. Choose your own adventure.with path function. We're going to pass in path function, the one that we just created. And that will allow us to use those two options. So assuming this is working correctly, we now won't be visiting pages like just the root slash or just like slash, whatever. This is going to be expecting all of our stories to have the story prefix. And one of the things we could also do with it, we could use a mux, so we could do something like new served mux. We could do mux.handle and do that, and then pass in the mux here. And we do mux. I'm not going to pass anything else just yet, but so the reason we're doing this as a mux is if you have a trailing slash in your in the default served mux that comes in the standard library, any paths that have that prefix will get sent to that handler. So basically, if we go to any other path that doesn't start with slash story slash, what's going to happen is our code is going to actually show a 404 page, but it's going to be the default one that the served mux returns instead of us. So let's make sure our code works. I think we've been covering a whole lot here, so you'll see we're now getting that 404 page not found. And this isn't the one we wrote. This is the one the served mux is giving us. So if we go to slash story, you'll see that this is now working. And if we go to slash New York, any of these are all working correctly now. And that's what basically what we were able to do by adding these two options here is we've now got a lot more customization possible with our choose your own adventure story. And we could embed it inside of another application if we wanted. All right, we covered a lot here, probably a little bit more than I should have for this video, but that's fine. I want to talk about two things quick before I end it. The first is these functional options. I named the two we have with, like they all start with and then something. You don't have to do this, and there's not really any guidelines as to like, yes, you should, no, you shouldn't. It's something I tend to do whenever I'm creating a package. So this package here, if I'm creating a package that has maybe a bunch of different types or a bunch of different functions exported, I will commonly use the same prefix for all of my functional options, or at least a specific type of functional option, because it makes it clear that that's what those are. It's just really quick way of making it really clear. You don't have to do that, but it's just something to keep in mind. And I think even if you were to run godoc, I think I have it up still somewhere. Yeah, you'll see here that when you run godocs, it really doesn't, it's not necessary because it'll actually go ahead and put these all under the handler option type. So it's not like a huge gain type thing. It's just something when I'm looking at the source code and everything, it tends to be a little bit easier for me to see all the things and know where they go. So I'll use it a lot. But you don't have to do it, especially if you only have a couple, we only have like 6 or 7 different exported things here. So maybe you don't need to do it here. It's completely up to you as to which you do. The second thing I want to say is definitely go check out Dave Cheney's stuff on functional options. He talks about building a calculator, I think it is. And it's just nice to see other options and how people are using them, because it's a pattern that I see it used a lot more in Go than in anywhere else, but it's a really nice pattern that's a lot nicer than chaining methods and things like that you'll tend to see and you'll tend to go to, especially if you're coming from another language like Java or something like that, where that type of pattern is a lot more common. So it's good to see how you can use something different in Go to write code that might be a little bit more idiomatic or a little bit easier to follow.